Imagine the Earth, our seemingly solid ground, suddenly convulsing like a giant in pain. Buildings crumble, the ground shakes violently, and fear grips the heart of all who experience it, because its destructive power far exceeds that of other natural disasters. The whole world suddenly shakes from under the ground. The entire area was destroyed. This is the terrifying power of an earthquake, a natural disaster that has plagued humanity for centuries. 55 earthquakes occur in the world every day, most of which we do not feel. Furthermore, depending on where the large earthquake occurs, tsunamis are generated, sweeping away the way of life in the sub-regions. Unlike other natural disasters, earthquakes cannot be predicted, making them more deadly than any other natural disaster. However, it can be anticipated that there is a high probability of an earthquake occurring in any part of the world. For ages, humans have grappled with the question, why do earthquakes occur? In today's video, we will discuss these topics. This upper layer of the earth is called the crust. This is where everything including water and land is located. The crust is divided into many small and large tectonic plates. And below the crust is the mantle. This mantle is not completely liquid and neither is it solid. The mantle is like a jelly. The point is that the tectonic plates are floating on the mantle like jelly. These tectonic plates create some effects. Now let's see what effects can be created between tectonic plates. First, tectonic plates can move away from each other. In such cases, weak earthquakes occur along with the formation of lowlands like canyons. In many cases, such earthquakes are accompanied by volcanoes, which usually form within tectonic plates in the ocean. Secondly, where two tectonic plates can collide directly, earthquakes occur as well as mountains are formed. The collision of two tectonic plates causes the rocks at the junction to fold up and up, forming mountains. Mount Everest was formed for this reason. Even the height of Mount Everest is constantly increasing because the impact of the collision of tectonic plates is still active. Also, the compacted rock layer continually expands upwards, resulting in the ever-increasing height of Mount Everest. The height of Mount Everest increases by about 4 mm every year. Third, side-by-side collisions between tectonic plates may occur. It can be caused by two tectonic plates moving in the same direction at different speeds or two plates moving in the opposite directions. This is why earthquakes have occurred in Turkey and Syria. It is a small-sized tectonic plate in the Anatolia Plate located in Turkey. This plate experiences downward pressure from the overlying Eurasia Plate and upward pressure from the Arabia and Africa Plates, causing the Anatolia Plate to move along this lift. Due to prolonged stress, a lot of energy was accumulated at the junction of these plates, releasing the energy by moving the plates sideways. As a result, devastating earthquakes were organized in Turkey and Syria. Fourth, when tremendous pressure builds up between two tectonic plates, one plate can move beneath the other, causing the overlying plate to rise above the sea level. This can lead to very strong earthquakes and potentially generate tsunamis. Such earthquakes mainly occur between the oceanic and continental plates. For example, in 2010, an earthquake of magnitude 8.8 occurred off the coast of Chile, which was 37,000 times more powerful than the bomb dropped on Hiroshima. As a result, the coast of Chile rose about 2.5 meters above sea level and moved about 3 meters. Now the question is, if the speed of the tectonic plates is very small, like 10 cm per year, how can such a huge amount of energy be generated even after the tectonic plates move at such a small speed? Firstly, the size of each tectonic plate is huge, and therefore its mass is huge. We now know that even if a massive object moves slowly, it has a lot of momentum and can make a big impact. For example, this cruise ship is moving at a slow speed, but because of its massive size, it has made a significant impact. Second, tectonic plates do not collide suddenly. Instead, energy accumulates over time. Later, the accumulated energy is released simultaneously, resulting in a large impact. Look at my hand to understand how it works. I want to free one hand from the other, but I can't, so I am constantly increasing my energy, which is now accumulating in the form of potential energy. Once my hands are free, all the energy stored here is released in an instant, causing my hands to go far. My hand wouldn't have moved so far if the energy hadn't accumulated here. The same thing happens with the tectonic plates. When enough energy is accumulated in this way, the plates are displaced and all the stored energy is released at once, and that energy spreads out in the form of waves, causing the ground to shake, a phenomenon known as an earthquake. When an oceanic plate pushes into a continental plate in the ocean, it causes the water to vibrate and create huge waves known as tsunamis. This phenomenon can be observed in coastal areas around the world. After an earthquake, the primary wave or P wave first comes to the Earth's surface. But this wave does not have much energy, so it is not very harmful. But the next secondary wave or S wave is very strong, and mainly due to this S wave, destruction takes place. Now, you may be asking if you can detect the P wave and predict the earthquake. This is true in one way, but the time interval between the P and S waves is very short, only a few seconds. Even if the P wave can be detected now, the S wave occurs before people are informed, so it is not possible to reduce the loss of life. But in this case, Japan is an exception. They have installed about 1000 seismometers in their country. When these seismometers detect a P wave, all of the country's traffic lights turn red. Additionally, notifications are sent to smartphones and red sirens are activated, resulting in a significant reduction in casualties. Scientists have been working on various methods to predict earthquakes, but none have proven to be effective. Since it's possible to know when an earthquake will happen, earthquake scientists advise building earthquake-resistant structures instead of relying on predictions to minimize damage and loss of life. There is considerable room for doubt as to how far we have been able to implement such instructions. In the event of an earthquake, it's important to know what to do to stay safe. Please remember the following safety tips for earthquakes. Take shelter in the open as soon as you feel the first tremor of the earthquake. If there is a helmet in the house, put it on your head and ask others to wear one as well. When leaving the house, if possible, ask everyone around to leave as well. Turn off the electrical and gas switches quickly. Do not waste time taking anything with you. If you happen to be stuck in the high-rise buildings with no way out, try to stay calm and patient. Consider whether your cries for help will reach rescuers. If any part of your body is trapped between walls, concrete ceilings, etc., try not to move much unless there is no other option, as it can cause excessive bleeding. If you find yourself stuck in the rubble, try to remain calm. Tension and fear can be harmful for you. If you are inside a building, get under a study table or bed. If there's no furniture to take cover under, find a pillar and sit next to it with your hands protecting your head. If there's enough time and it's safe, move to the roof. And if you are in a car, stop the car and stay inside. Above all, stay calm during an earthquake. And be sure to teach these things to children at home so they can do these things on their own when you are not around. The junctions of tectonic plates are mainly prone to earthquakes. It is worth mentioning here that many countries in South Asia are located at the junction of several tectonic plates, and the plates are quite active. There is enough kinetic energy at their junctions. These plates have not seen major earthquakes for many years, so scientists believe that there is a lot of energy stored in these plates, and that energy can be released at any time by a large earthquake. If this occurs, it will undoubtedly be one of the most catastrophic events in the world history, as the infrastructure of these countries is unable to withstand major earthquakes. Humans have only been able to dig 12 kilometers below the Earth's surface, which is very small compared to the Earth radius. This raises the question of how people know about the center of the Earth. Additionally, if we were to keep digging from one end of the world, could we really reach the other end? You can watch this video to explore these questions. If you find the video helpful, feel free to subscribe to the channel.